Alternatively, I see a good discussion about the source and age of these materials that we're going to encounter. And Jim Head, I don't know if you've had a chance to read some of these conversations, but I wonder if you wanted to weigh in about lithology of class and whether they are dated by emplacement or not. I think you're muted.
Yeah, I did not read them, but I'm trying to now. But anyway, the bottom line is, I think, there's a whole series of questions here. We faced this ever since we tried to, years ago, send a sample return mission to the South Boykin Basin. Where do you go? What do you do? If you're going to bring back a sample, it's got to be very carefully selected, and it can't be just, oh, it's going to be pure impact melt, therefore we'll date the basin. So it's a really, really complex situation. But I think in order to start that, you really need to have kind of the statistics on what is likely to be there at a given site so that we can then get, I would say, grab sample is not a good thing. It's just like, oh, we're just grabbing something. No, no, no. It's more a bulk representative sample at the best possible place. So you want to go, for example, if the um, at the Artemis, at the massif, basically of the South Pelican Basin, it's going to be much easier. Okay, it's more likely that we're going to get material there, and we select a bunch of these things to try to get something that might represent both the mantle material as well as the impact melt potential age. Okay, or shock reset age. Um, Otherwise, we have to do it statistically, and that's going to be a lot of what happens because Barbara Cohen has done some really great work looking at breccias and small samples, and then try to look at the statistics of these things to piece this sort of provenance together. So it's going to be statistical. Hopefully we'll see some boulders to get some context, as Jack Schmidt and Dave Scott did on Apollo 15, 17, and also on Apollo 16 with house rock and outhouse rock. Um, but it's going to be a really tough situation. And I want to make one last point, which is remember that the astronauts aren't going to be wandering around in the South Circumpolar region with a geological map. There's going to be a lot of recognition of landmarks, et cetera, and predetermined traverses, which are flexible. In Apollo, it wasn't about just scripting, it was about guidelines. And they did a lot of real-time thinking. Remember that the people who have the most cognizance of what's going on are the people on the moon. That's the astronauts on the moon. They remember the word situational awareness. They're going to be there. They're going to see what's going on. And training in Apollo, the idea was T cubed, train them, trust them, and turn them loose. And then we're here to help in the back room in mission control, but they're the ones that have the real-time kind of like situational awareness and can make the best judgment. Sorry for the little speech. Thank you.
Appreciate it. Thanks. Laz, I see your hand up. Do you have a question?
No, I wanted to hit the applaud button for what Jim just said.
Okay. Well, while you're unmuted, I think we have a question related to Viper. If you could respond from Stephen Gracie. Are the coordinates for the Viper landing site available? Are there multiple sites due to solar illumination date launch? Does a launch scrub influence the site selection at all, or is it set in stone?
Oh boy. Let's see. We have a place we're planning to go, and I let people higher up in the mission decide exactly how they want to communicate all that information. I can say, I think this has been stated multiple times, is that the landing site, the general area was picked because it's relatively robust to when we launch and when we land. There are some sites where if you the availability of sunlit spaces is limited, and Viper being solar powered, one of the key restrictions is how long we're sitting in shadow. So we can, we try to find places where even when we lose sight of the Earth, so we need two things. We need to be able to talk to the Earth to operate, and we need to be in sunshine. And so trying to have both of those being available for as long and as robustly to launch date was a big driver to where we're going. There are ongoing discussions about, down to the tens of meters, exactly where we're going to land. That's a discussion with the providers for the lander. And yeah, I think that's about as much as I feel comfortable saying. I don't know more. If I said more, I'd be saying something wrong.
Yeah, no problem. Thank you for that.
Ariel Deutsch shared the abstract that has the coordinates in the chat too. So if people want to go track that down, they can.
Okay, I see another question for Jim from Hannes saying that they were not able to find actual crater count areas of your map. Any chance of adding these as supplemental online material later?
The answer is yes, and we're actually getting it on Zenodo too, so that everybody can have complete access. This has been a little bit of a problem, but not insurmountable. We're working on that now. So yes, definitely.
Thank you.
I thought part of that was in the supplemental material, but anyway, let me go back and check. And I also just posted a couple of extra references that might be useful for both mapping and some background as well for if anybody is interested. Thanks.
Great. I'll swing it back to Laz. Question from Brent Gary. How rapid a turnaround do you anticipate for creating traverse feature maps along the route for Viper based on surface views? Will Geologic map along the traverse be similar to what Larry Crumpler did for MER be done for Viper?
So I'm trying to figure out how to say this most correctly. There's an ongoing level of detailed planning for exactly where we expect to drive the rover that's ongoing right now. So there's an expectation that we'll have a pretty good idea for the entire traverse before we launch. Obviously, we'll learn things and we'll adjust. But the ability to ingest a bunch of new map products into the operations environment in real time is limited. Let's just say the IT systems are not designed to have a lot of people futzing with the data that you use for operating the vehicle. So there's a lot of discussions we expect to happen outside of the immediate mission operation setting, but inside where there's actual commanding and decisions being made, I don't expect to be creating a whole bunch of new maps. On the other hand, the tools we're using allow real-time annotating and putting in descriptions of what we think we'll see and so forth. So I'm not answering exactly the question because I think we're working in a slightly different ops, whatever you call it, the scenario. It's very fast-paced because it's 24/7 real time while we're operating, and we will not survive past our stated lifetime. Once we go into the real lunar night, it'd be completely unreasonable to expect us to come out the other end. So the kind of planning we're used to doing for the Mars rovers really is hard to translate. We don't have the time to sit there and cogitate and make nice maps. There's a lot of things we do ahead of time and things we do real time, and in between we're missing a bunch.
Right. Well, thanks for that insight to Viper, and I want to thank our speakers for this session.